So I'm going to give you a quick run through of my FYP project. So the first thing to know is there is three different projects, one for each skill rating system. All are basically identical apart from the code for the skill rating system. So the most important concepts to understand is everything is held in these data tables. So this one is the server data table. So this is what the server would hold in a real world scenario, and obviously I have bot data, which is the reaction times and shot accuracy of each bot. This obviously would be a normal player, but because we're using AI, I've had to set this one up. So I'll give you a quick run through first of all of the server controllers. So obviously all the variables and structs are set up here because header file. There's loads of Blueprint implementable function because I use a combination of Blueprint and C++. So let me get my notes up quickly. So at the start of this, it adds all of the data from the data tables to structs, so it's easy to access in the code. It also orders all the bots into an order map, so we have them in order and not in order, so we've got two maps to control everything. It also gets access to all the spawn controllers, which are basically like the games. Finally, it starts the lobby making processor, and then it shoots over here. So first of all, it gets the order map of all the bots in their skill rating order. It then clumps them into groups of 10, so 10 closest skill rating together. It then sorts them into their teams. So the team sorting is actually just it swapping basically all of them round to randomly shuffle to give a bit of randomness to the experiment. If not, the same bots might be queued together constantly and it would give like inaccurate data. It then adds them to red and blue lists. That's my two teams, is red and blue. After that, it goes to the server selector, and this basically then finds an empty server and then runs the create match when there's an empty server. Create match is bit longer. It first of all binds all of the callback events that it needs back to this script. So it does all of the skill rating changes and when the round ends. Then obviously adds the bots to the spawn controller like lists, so it's got a map there too. And then it also calls the spawn like start the match, basically is spawning all the AI and it starts the match. Basically, after that, this is the order map, so this is just it sorting all of it, and this is check for is the server empty that's used later. So once the match is finished, it will do a callback event and run this script with the server ID and bots ID in a list. This basically empties the server out. It takes the bots stat maps, like maps, and changes their in-game status to false and changes the game played to +1. It then also does a couple checks for like if there's still servers full, and any checks for any leftover bots, because sometimes there was rare cases where bots were being left over. And then obviously this check down here is to check if all the servers are empty, and if they are all empty, it will restart the whole system, so I don't have to manually restart it. At the bottom is the bound functions that are called from the spawner script, or yeah, the spawn controller script to change obviously the bot's skill rating and stuff, but that's called from inside the spawn script. The spawn script. So at the top, obviously, it's just setting a bunch of arrays up, stuff like that. Obviously, this is where everything gets called. This is where it gets all the bots from the blue list and the red list, and adds their accuracy, reaction times, and stuff like that. It then spawns these bots in the world, and they obviously go out and fight. Basically, every time a bot dies, this script is called to see if there's any enemies left. So this is how it works out if the round is over, because it checks, oh, there's no red bots left, blue team clearly killed them all, and then runs the reset round, which basically just goes through, resets, changes the score, and checks for if the round, if it's reached 7, which is the end of game for us, and if it has, obviously it'll run the endgame script. If else, it will respawn all the bots back on their spawn points, which do switch on round number 6. This is what this check is. So just to make the maps totally equal, they swap spawns halfway through the match. Obviously after this is the true skill calculation. This one, I'm actually on the percentile branch of this tree right now, so this isn't called at all, but this is the maths for the true skill calculations. And this is like the team calculation for the Mew to work out the new Mew. This is obviously the old ELO calculation that is used for the ELO set of data, and that's how it's done here. And the percentile based one's here at the bottom here. The endgame script just obviously runs when the game's ended. Obviously we're calling a percentile based skill rating to work out all the new percentages. This is old code from when we had the true skill calculations. That's how it was done there instead of a separate function. It then broadcasts obviously the server and all the bot IDs to remove themselves from the server. And then at the end it's just restarting the game, resetting all the values, so next time when new bots come in, it's empty and clear and basically like a fresh one. So the bot CPP, actually majority of the bot is done through Blueprint because of the decision trees that you can have. So I've got a few Blueprint implementable functions that are here, and obviously I just did the really easy kill death in C++ instead of having to do it through Blueprint. So I'll show you them now. So the main one is this bot one. So obviously we'll start up here. This is just the bullet firing. This is it aiming, shooting at an actor that it is seen. It uses the visual sense as its main sense to sense targets. This is its received damage and how much it's meant to take. Obviously it's got to do checks so if it's being shot by a teammate or not. Well, there's no team damage in this, so it checks if it's shooting the right player. Obviously there's the death that despawns it and stops the logic of it. At the start of the game it's either set to red or blue, and it's done through this sort of decision process down here, and changes obviously the tag on the player and sets the material so we can easily see. And finally it's the data writing, so at the end of each match it will write a little data report that I can use and analyze obviously in my like review section. This is the tree. It's quite basic, so it uses the EQS query system to decide where it's moving. So this one here is obviously it just navigating around the world, so it doesn't have a target actor, so it's not aiming at anyone. And then obviously it runs the EQS system, returns a location, and it moves to the location. This is the chase sequence, so once it has found a target, it will start the shooting service, and then it will also try to move to the target, so run at the enemy and shoot. Obviously there's even more to it, so basically we have this check for if it's at a lower health, it will run like this combat EQS, which will sort of make it strafe left and right to try and dodge bullets. This sort of adds a bit of uniqueness and like not just bots running at each other, it actually gives them a bit of thought. And finally, if it's below a certain amount of health, it will actually use this retreat EQS, so it will try and run as far away as possible and get to like a piece of cover or something like that, and this is what this EQS system does. So apart from that, I'll go to shooting service. So the shooting service is pretty simple. It's just like it basically finds them, shoots a sphere at them, and then basically fires a bullet once it's located the actor. This was done a while ago, so I can't really remember to do it. This is the file writing on the server side, so a lot of the file writing uses a lot of strings, and I just find it easier to do in Blueprint. A lot of this is redundant. The main one that gets used is actually this really short one, which literally takes the current map, makes it into a text, and then literally writes it to obviously my backup files, and it runs this every time to give me all the match data report that I use to break down. A lot of other things are just editing the map. Instead of directly calling it, I can rewrite the map with either the changes or whatever, but that's pretty redundant now apart from this code. I made all of them obviously do different ones. So this is the true skill one because it's got a different struct. Same up here, this is the elo one, but it's not particularly used anymore. Um, Apart from that, that's a lot of it. I'll show you. Obviously, I added a teleporting system to make it nice and easy to get around the map because it's so large. But apart from that, that's the whole project.